You've heard fat is bad 1,000 times. Clogged arteries, low-fat diets, avoid butter. It's a story we were told for decades, but chemistry tells a different one. The way fat is built, at the molecular level, decides how it behaves in your pan and inside your body. Let's take a closer look. There are three main families of fat: saturated, monounsaturated, and polyunsaturated. These words aren't about good or bad. They're about chemistry. How many hydrogen atoms fill the carbon bonds? That simple detail changes everything, from how it melts, cooks, or even supports your brain. Saturated fat is fully loaded. Every carbon atom is filled with hydrogen, straight, solid, stable. That's why butter, ghee, and tallow stay firm at room temperature. They resist oxidation and handle heat like champions. That stability is their superpower. Less reactive, more predictable, less likely to turn toxic when heated. Monounsaturated fats, like olive oil, avocado oil, and peanut oil, are flexible. They're missing just one pair of hydrogens, creating a gentle bend in the molecule. They pour easily, stay liquid at room temperature, but thicken in the fridge. They're stable enough for moderate heat, and they bring flavor and flow. Think of them as the artists among fats: fluid, balanced, adaptable. Polyunsaturated fats, PUFAs, are the fragile ones. Missing multiple hydrogen pairs, they bend in several places. Always liquid, always reactive. That makes them unstable when heated. Inside your body, those reactive sites can easily oxidize, creating compounds that irritate cells and accelerate aging. When heated, those oils don't just break down, they transform. Oxidation is oxygen's love affair with unstable molecules. It's just chemistry, but inside a hot pan, that chemistry creates peroxides, aldehydes, and other breakdown products. Over time, those reactive molecules can overwhelm your antioxidant defenses. The more double bonds a fat has, the faster it breaks down under heat. Here's the takeaway. All foods contain a mix of fats. Only the ratios differ. Coconut oil and palm, mostly saturated. Butter, around 60%. Beef tallow, 50%. Lard, 40%. Even olive oil has a small amount of polyunsaturated fat. The idea isn't to fear oil, it's to know which ones belong on the stove and which ones belong in your salad. When you cook, heat changes everything. Butter stays stable, olive oil flows, seed oils smoke. The same chemistry that makes them liquid also makes them fragile. That's why chefs and grandmothers both knew: use stable fats for heat, save delicate oils for cold. So how should you cook? Use heat-stable fats for frying and searing. Store oils away from light and air. Never reuse fried oil. It's a chemical mess. Your kitchen is a chemistry lab, whether you realize it or not. We evolved with these fats. Before refrigeration, saturated fats kept our ancestors alive. Even our brains, nearly 60% fat, are built on stability. Cholesterol isn't your enemy, it's your engineer. Fat isn't the villain, it's the foundation. This is education, not medical advice. But if you understand chemistry, you understand your body. In the next episode, we'll go inside the pan to see what actually forms when seed oils meet heat. Subscribe because they don't want you to know what's next.